All right, we're starting the rationals unit, and I absolutely love rationals because rationals are fractions and factoring combined. So it's a great deal of fun. You get this really nasty looking problem, and then it simplifies down to something like 5 over x. It's just like a puzzle. So it's a great deal of fun to solve. Today's learning target is to be able to simplify rational expressions. Now, to simplify, we are going to start by factoring everything we can. Then we're going to simplify any monomials we're able to pull out. So if you have any GCFs, those will have to be simplified. We will then eliminate any common binomial factors. Keep in mind that you can only eliminate factors that are multiplied. Okay, you cannot eliminate anything that is added or subtracted. So what do I mean by that? A lot of times we get expressions like this, for example. And what I will see students do is I will see them cancel out the x's. Well, you can't do that, right? The x in the numerator, the x on top, is being added to 1. That has to go together as a married couple, as a pair, right? We can't cancel out the x's because of that addition sign. So be careful and don't eliminate something that can't be eliminated. All right, so for our first practice problem, we have very kindly already factored for you. And as I'm looking here, right, I can simplify my GCFs. 2 goes into 2 one time, and 2 goes into 6 3 times. I have an x minus 5 on top and on the bottom, and those are my only common factors. So my answer is going to be x minus 3 in the numerator, 3 times x plus 3 times x plus 4 in my denominator. You do not multiply this back. Okay, it's far more useful in this format, and you want to leave it in factored form. Let's take a look at number 2. In number 2, we have a GCF of x squared and x. So x goes into x one time, and x goes into x squared one time. I have 1x remaining. I've got an x plus 7 and 2 x plus 7s on the bottom, so I'm going to take 1 out. I have an x minus 5 and an x minus 5. So this leaves me with x on top, x plus 7, and x plus 3 on the bottom. Okay. Our next one looks like something from our last unit on exponents and radicals. 5 goes into 5 once, 5 goes into 15 3 times. X goes into x once and x cubed with a remainder of 2. And y goes into y once and y cubed with a remainder of 2. So this leaves me with x squared divided by 3 y squared. All right, finally some factoring. In number 4, I need to pull out a GCF. In my numerator, I can pull out a GCF of 4, leaving me with x plus 5. In my denominator, I can pull a GCF of 3, leaving me with x plus 5. Those x plus 5s can be eliminated, and my final answer is 4/3. I love rationals. All righty. Number 5, that numerator cannot be factored, but I'm going to put parentheses around it to remind myself to keep the y and the 8 together as a couple. Okay, so 48, 8 times 6. I want the 8 to be positive so that I end up with a positive 2. As I look at this, I have y plus 8 in both the numerator and the denominator. The answer here is 1 over y minus 6, right? I eliminated everything from the numerator, but I need a placeholder there. You can't leave it blank. It is still a fraction. All righty, number 6. Let's start by pulling out GCFs. I can take out a 2, r squared minus r minus 20. That'll need to be factored further. And in my denominator, I can take out an 8, and that's as far as that goes. So let's see, 2, negative 20, a negative 5, positive 4. That will multiply to negative 20, but add to negative 1. Now that everything is factored, 2 goes into 2 one time, 2 goes into 8 4 times, r plus 4, and I have r minus 5 over 4. Now, number 7 is a little different. Let's start by factoring that numerator, though, right? Difference of two perfect squares. So square root plus square root minus square root. Now, here's the problem. I'm not going to be able to cancel this p minus 7 and this 7 minus p because the order in subtraction matters. So what you can do is take out a negative 1. All right, let's do that. Negative 1. And if I divide this by negative 1, right, negative a divided by negative 1 is positive a, and positive b divided by negative 1 is negative b. So if you factor out a negative 1, you can switch the order in a subtraction problem, and that will allow me to do some canceling. Right, p minus 7, p minus 7. Now, when I go to write this final answer, we don't write denominators of 1. This denominator is negative 1, so I'm going to move that negative sign up to the numerator so that it doesn't get lost. Any number divided by 1 is just that number, so we don't write fractions with denominators of 1. Pause the video and try number 8 on your own, then come back and check with me. All right, I'm going to pull out a GCF of 3a, leaving me with 4a squared minus 1. And in my denominator, 6a, leaving me with 2a squared plus 1. That numerator can be factored further. I have a perfect square minus a perfect square. Difference of squares. My denominator is beautifully factored. And now I'm ready to cancel out common terms. So the a divided by a is 1. 3 goes into 3 one time. 3 goes into 6 twice. 2 a's plus 1's can be eliminated. And I have 2a minus 1 over 2. All righty, pause your video, try number 9 on your own, and then come back to check with me. Pull out your GCFs first. Both that numerator and denominator can be factored further. So 2 times 3n plus 1, n plus 1, and 2 times n plus 1, n minus 1. Eliminate common factors, and my final answer is 3n plus 1 over n minus 1. Okay, next up, pause your video and try it without me. All right, number 10. Last one for this lesson. The fact that W is at the end concerns me. I'm going to start by pulling out a -5, giving me W plus 9. And here, 3W, W, 3 times 9 is 27. So -9, -1, -27 minus 1 is -28. A negative times, small mistake here. +45 divided by -5 is -9. Eliminate. -5 divided by 3W minus 1. All right, so take a moment, write your summary.